Welcome to the 10x Roadmap to AI Fundamentals. This video will focus on mastering the core concepts of artificial intelligence. Intelligence is defined by acquiring knowledge and applying relevant skills. Knowledge is an understanding of facts, while skill is the practical capacity to execute tasks and solve problems using that knowledge. Knowledge is acquired through various means. These include perception, introspection, memory, reasoning, and testimony from external sources. Artificial intelligence is dedicated to creating machines that mimic human intelligence. Key cognitive functions include learning new information, reasoning using rules to solve problems, and decision-making to choose the most effective path. Training is the process of feeding data into an algorithm to adjust its internal parameters. Learning is the resulting ability of the model to recognize patterns, make predictions, and improve its performance through experience. AI systems function through a pattern recognition cycle to turn raw data into actionable intelligence. This involves analysis to identify patterns, synthesis to build a predictive model, and output to generate content or recommendations. Traditional programming systems face complexity and scale barriers, particularly with tasks that lack rigid, deterministic rules. They struggle with complex language-based tasks, unstructured data, and generating human-like content. Traditional programming is deterministic, relying on coded rules for consistent outputs. AI is probabilistic. It trains on data to recognize patterns and adapts to complex, unpredictable inputs, making it ideal for tasks like image recognition and NLP. We will now discuss good old-fashioned AI, also known as symbolic AI. Symbolic AI is a rule-based intelligence that uses hard-coded rules and logic for decision-making. It is logic-driven, often implemented as expert systems, and is highly explainable because decisions can be easily traced. A rule-based expert system is the core of symbolic AI, using if-then logic to emulate human knowledge. These systems operate with a fixed inventory and lack the ability to adapt or learn from new data. Rule-based AI systems have two core components. The inference engine is the system's decision maker, applying logical rules to draw conclusions. The knowledge base is the system's repository of expertise, storing curated facts and expert logic. This diagram provides an operational overview of a rule-based expert system. The inference engine uses the knowledge base and data to generate decisions that are communicated to the user via the user interface. Here's a simple example of a rule-based AI system. The infer function checks rules sequentially, returning false if any rule fails. The complete source code is available on GitHub. Rule-based AI systems have several limitations. They struggle with adaptation and scalability due to rapid complexity growth. They are also limited by the labor-intensive knowledge acquisition bottleneck and struggle with uncertainty and generalization outside of their explicit rules. Now let's discuss machine learning and the modern era of AI, which overcomes the limitations of rule-based systems. Machine learning enables systems to learn autonomously from data and improve performance over time, without explicit programming. This involves autonomous learning and pattern recognition to identify structures and trends. Modern AI fundamentally relies on data-driven algorithms. These mechanisms identify complex patterns and make decisions with minimal human intervention, forming the core of contemporary artificial intelligence. In machine learning, a computer system or algorithm, known as the machine, learns through experience. Key tasks include prediction and pattern recognition, mimicking human learning by analyzing data instead of hard-coded instructions. Mathematically, machine learning involves finding and improving a formula that produces desired outputs when applied to training data. Tom Mitchell formally defines learning as the improvement of performance P on task T with experience E. The machine learning workflow is an iterative process. It includes data collection, pre-processing, model training, evaluation, and finally, deployment to ensure accurate application. Linear regression is an example that models the relationship between a dependent variable and independent variables. The core goal is to find the best fit straight line that minimizes the error between the line and the actual data points. Linear regression uses the straight line equation, y equals mx plus c, as its predictive model. The training process optimizes the values for the slope m and the y-intercept c. Linear regression improves through an iterative process. It starts with an initial assumption and uses data collection to progressively refine the model for a more accurate outcome. This code snippet illustrates linear regression using scikit-learn. The fit method is used to calculate the optimal slope and intercept from the training data, and the predict method is used to generate output. Deep learning is a subset of AI that uses multi-layered artificial neural networks. It excels with complex, high-dimensional, unstructured data like images and audio, capturing non-linear relationships and abstracting features automatically. AI applications are diverse, spanning generative AI for creativity, enhanced productivity in daily tasks, improving data processing and software development, and specialized corporate and medical domains. Thank you for watching this video on AI fundamentals. You can find related articles and the source code repository through the links provided.